We always observe an impact of motion produced by the moving object, and it depends upon the mass of that object and its velocity. And when Newton found about it, he called it linear momentum, and we oftenly and commonly call it today as momentum. Hello everyone, this is Devinder Kaur and you all are welcome to my YouTube channel, The Enlightened Room. And today in this video we will discuss about momentum. Newton found out that momentum is the measure of the impact on the moving objects which depends upon its velocity and its mass. So clearly, if we want to mathematically define what momentum is, then it is the product of mass of the moving object with its velocity. So we denote momentum with P here. This P is momentum. As we mathematically are trying to define it, so it is product of mass with velocity of the moving object. So now this is, you can say, the formula for finding momentum, and this formula is beneficial in very numerical problems. So let us more study about it. This P is momentum here. This mass, this M is mass of the moving body or the moving object, and this V is the velocity of that moving object. Now just like velocity, it has both direction and magnitude, so it is a vector quantity. Similarly, the momentum has both direction and magnitude, and hence momentum is also a vector quantity. Now what are the units of momentum? Let us study about the units of momentum. Since mass is calculated in kilograms and velocity is calculated in meters per second, so the unit of momentum is kilogram meters per second. It is simple as that, right? So there is one more thing about momentum, and that is, if we twice the mass here and the velocity remains unchanged, there will be a change in momentum, and that means the momentum will be doubled. Now if the mass remains the same or unchanged and we double the velocity, again the momentum will become double. Because momentum is product of both mass and velocity, and whatever there are changes on mass as well as on velocity, there will be the changes on momentum. Okay, so if both are reduced to half, momentum would also get reduced to half, and if both are doubled, momentum will become 4 times. Well, when both are reduced to half, momentum will become 1/4. Okay, so this is about momentum. Now let us discuss about its physical applications, or how do we calculate it physically, or how we see it physically. Well, you would have seen that in the game of table tennis, if the ball hits a player, he is not hurt. But when a cricket ball moving at the same speed as the table tennis hits a spectator, he is hurt. Well, this is because cricket ball is much heavier than the table tennis ball. Also, a truck moving at speed as low as 5 meters per second may kill a person coming its way. This is again because the heavy mass of the truck. Again, a bullet of small mass fired from a gun may kill a person. Well, this is because large velocity of the bullet. Now let us consider more examples of a bullet. A bullet fired at a wooden boat can destroy it, but a small stone of the same mass as the bullet when thrown at the boat will hardly cause any damage, and if you replace it with a sponge, I don't think so that it will move that far. Okay, so although their masses are same, the high velocity of the bullet gives it a large momentum, and this causes the damage. Now let us discuss more about momentum. Well, from Newton's first law of motion, we had learned that a force is required to change the velocity of the body. When the velocity of the body changes, its linear momentum also changes. Therefore, an external force is required to change the linear momentum of the body. So today in this video we discussed about linear momentum, or we simply call it as momentum. In the next video we will discuss about Newton's second law of motion. Until then, stay healthy, stay safe.